Welcome to the Medicine and Machine Learning podcast. Today, we are thrilled to have Dr. Stephen Hart as our guest. Dr. Hart is a pioneering expert in bioinformatics and artificial intelligence with over 13 years of experience at the Mayo Clinic, where he serves as a senior associate consultant in AI. He has been instrumental in developing Genome GPS, Mayo Clinic's primary DNA sequencing workflow, and has played a transformative role in shaping the fields of genomics and digital pathology. Beyond his work in bioinformatics, Dr. Hart is a thought leader in AI, cloud computing, and cancer genomics. His groundbreaking contributions have led to advancements in understanding inherited cancer risk and improving digital pathology workflow. With over 100 peer-reviewed publications, Dr. Hart's innovative algorithms are driving efficiency in genetic predisposition testing and enhancing precision healthcare. Join us as we explore the cutting-edge intersections of medicine, AI, and genomics with Dr. Stephen Hart. Dr. Hart, really excited to talk with you today. But for the listeners that don't know you, would you be able to start off with, a brief introduction with your background and your role at the Mayo Clinic?
My name is Stephen Hart. I'm a faculty in the Division of Computational Pathology and Artificial Intelligence. That's in our Department of Laboratory Medicine and Pathology, which is one of our clinical divisions that do all of our laboratory tests. I got my PhD in 2011. It was actually in pharmacology, even though I've never done it a day in my life. It was a really interesting time. We were trying to do this drug study, and we wanted to look at how drug metabolizing and expression changed over time. And this new sequencer came out. And with the sequencing technologies there back in the day, we could basically do this entire 5-year grant in one run on one of these brand new sequencers. And so that kind of led me down the path of getting into the informatics and learning how to code, and basically being the first bioinformatician at our institution so that we could actually process some of this data. I was really fortunate to have a really flexible advisor, Dr. Jabozan.
It sounds like you were swimming through uncharted waters at the beginning of your career, and it sounds like you're still doing that today. So is there something about exploration and experiencing things that haven't been done before that drives you, or?
Not going to sound very noble. So I always figured there were two types of being smart, right? There's book smart, which is what most doctors and lawyers and, all those people that go to school forever.
Yeah.
do. and then there's me with more of a street smart kid. I didn't have a big high school GPA, and I wasn't planning on going to college, and it's just not a thing that we used to do. So I think that's probably where I like it more, is where the answers aren't known. And I'll figure out how to get through it, because that's where my strengths are, not about knowing things that are already known.
You mentioned that you were quite street smart. Is there something in your upbringing that might have honed your intelligence in that way and maybe ultimately led you to being interested in machine learning?
I didn't have anything that really shaped my interest in machine learning. I never even thought I was going to go to college. It was never really in the cards for me. So what happened is, after high school, I ended up working at a factory. And it was a factory that made paper products. And I kept seeing people either get hurt because you worked on some pretty dangerous machinery, or you get laid off, or you didn't know if your job was going to be there, which, by the way, that company doesn't exist anymore. So I'm glad I made a move. But basically, it was, we were going through some turmoil at the factory, and then some people had mentioned, maybe they were going to go back to school. And the thought had never even crossed my mind. And then it made me think, well, maybe I could do that. And I was talking to some people, and they said, yeah, you probably wouldn't like it. You wouldn't do well here. And me being me, I took that as a challenge. And I've carried that chip on my shoulder ever since, to prove people wrong, because that's a strong motivator for me. So the harder and more complex the problem, the more people say, well, we can't really do that. I'm always challenged to say, well, yes, we can. You just have to figure out how. That's kind of how I got into genomics, because at the time, that was the biggest and most complex data with the sequencing informatics, because it wasn't as well defined as it is now, with the benefit of 10 plus years of hindsight. But especially with digital pathology now, even beginning to dwarf the size and complexity of genomics, I just really like being in that space where we don't really know. There's not a clear path, right? I'm the guy that wants to go through the jungle and hack my own sort of way through.
You're comfortable with uncertainty. And I would love to dig more into that. When people are faced with challenges, it's really easy to sort of react in a few different ways. So a lot of people crumple under the challenge, or they struggle with it, or take other people's opinions too literally and take them to heart. But there's also some people that use that disbelief or that chip on their shoulder to fuel themselves to keep pushing forward. And I'd love to know if that was something you felt like you've always had, or if it was just that moment that sort of changed things in your life, or, take me there.
I don't know. I mean, I've always just been more of an independent person, and I think that's actually been really good for me, because at the end of the day, I have to answer to myself. I don't have to answer to anybody else. I have to answer to myself. If I'm not true to myself and I don't believe that I can do it, then how can I convince somebody else that I could do something? I think there's a lot of personality in there. Some people have it and some people don't, but some people have much better, more healthy attributes other than a chip on your shoulder. Because apparently that's probably not the greatest for your overall mental health.
I would argue that, if it helps you get to where you want to go, maybe it's all right. But yeah, I could see how it would be bad to always have that negative emotion in you, I guess. You mentioned that you worked at a factory, and now I'm kind of curious about that. Do you have any crazy stories from that time that you can share, or, any big moment that made you be like, okay, I have to get out of here?
There was a guy that died.
Oh my God.
And the reason that he died is he was dying for a practical joke, because he was carrying a toilet up the stairs because his manager didn't allow him to take restroom breaks. And he was going to put the toilet right next to his manager's office and say, if you're not going to let me go to the bathroom, I'm going to go to the bathroom right here by your office. But he never got it up there because he tripped up the stairs and the porcelain broke.
Wow, that is actually a crazy story. And it seems like, yeah, that was sort of the result of the poor work environment. And ultimately, that was his choice to do that. But still, that is crazy. So, yeah, so after working at the factory, you went back to school and you ultimately ended up at the Mayo Clinic, where you are now, and you've been making a really big impact there. Could you share with me what led you to the Mayo Clinic and what makes the Mayo Clinic unique in helping you pursue your intellectual interests?
Sure, you want the real answer or a manufactured answer? Because
Please give me the real answer.
the real answer is my wife said you can be within a 5-hour driving radius from my family, because she is a very small town girl and very tight knit family, and all of her family lives in this one area. So that was my radius. Now I ended up going a little bit beyond that, but it worked out. She was okay with it. I wasn't going to go to the coast, even though I have more of an East Coast sort of mentality. I'm more of a Midwestern person that like to be in the smaller towns. I don't like big cities, concrete jungles. So I wanted some place that was out in the country-ish, or at least in the middle of the country. So that already limits your options. But I want to go to the best place too. I didn't even know Mayo was in the Midwest. I thought Mayo was someplace in New York, because,
Yeah.
well, Rochester, that's in New York, right? Now, it turns out there's a Rochester, Minnesota. I was completely oblivious to all of Mayo before going and getting my PhD and kind of going down this path. So I just ended up cold calling people. I was reading some papers that people had published, and I just called them up. I'm like, hey, I'm doing this new bioinformatics type stuff. Do you know if there's anything around that, that you might be able to use those sorts of skills for? And I eventually got in touch with the right person, and things just kind of fell into place there.
I think that's honestly an amazing reason to go to the Mayo Clinic. Happy wife, happy life. I don't have a wife yet, but when I find the victim, I'm sure I'll always try to make her happy. So yeah. So would you also be able to touch on maybe some of the things that surprised you about the Mayo Clinic? Some of the things that you think really help you push your interest forward?
Obviously, the first and the one, especially based on the last conversation that we had, was this culture that they have. We were talking about that factory culture, and here the needs of the patient come first. Anytime you ever talk to anybody at Mayo, you're going to out hear that sound at least once, right? Because this is ingrained in our DNA. And what it really means is it gives you that latitude to think, is this really helping the patient? And if not, I can run this up the flagpole and I don't have to worry about making somebody mad because we're all in it together. So that culture is number one. That was great. The second thing that I made Mayo really unique is when I was doing my PhD work, we were mostly focused on animal studies, a lot of mouse work. And I felt like there was something kind of lacking in that translation gap. So I wanted to work with human data. And so, Mayo, they got lots of data, right? And then I get there and it was more data than I knew what to do with. And it's continuously growing every year ever since I came. So that's been great for me because that was really one of the big things I wanted to do is I wanted to make sure I was having an impact and working on something that I could explain to somebody why I was doing it. Because when you work with mice, it's great if you cure cancer in a mouse, but it doesn't mean it's going to work in a human.
I think that's definitely one of the things that's pretty interesting about the Mayo Clinic is, like you said, how much data they have. But would you say that the data is high quality, or is a lot of it like unstructured notes and stuff that you need to add structure to? Or
if by quality you mean, do I have data for a very rare thing that's only been seen a few times in the world, then yeah, that's an incredible asset. If you are talking about quality in terms of, is it all structured or is it unstructured? There it really depends. Some things can't be structured. So a free text report that is common in pathology in the department that I work in is very commonplace. It's what the field works on. Me being a data scientist, I prefer to house categorical variables and clean data and things that are much easier for computers to work with rather than humans. So there's always that disconnect there between structured and unstructured, but we have made the commitment to go digital in a lot of things, to digitize not only practice, but also historical data and figure out how to use that information as we go along. So I think that's a work in progress.
The Mayo Clinic has shown a strong commitment to educating its staff on generative AI and automation, and as evidenced by initiatives like resource development from the Advanced Digital Education team and hosting AI conferences that we met at. As a leader in AI at an institution that embraces technological advancement, what do you see as the most critical issues and priorities that large healthcare systems should address in the next 10 years regarding AI? And what early steps are being taken to achieve these goals?
This is why I love being at Mayo, working in a clinical department, because my future doesn't ride on the next few words that are coming out of my mouth. I am an AI scientist. I work in AI, but I actually don't think that AI by itself is really the technological advancement that is going to have the most impact, especially in the short term. I say that because leading up to this AI revolution, we have started to notice where we have deficiencies as a system, right? So the biggest hurdles I've seen when we wanted to just jump in and apply this new AI fancy stuff, we realized, well, we don't really have the best data literacy. What do we mean by data literacy? Well, that's just understanding what data do you have? How do you use it? What are the best ways to store and access that information? Those sorts of things. So just knowing about data. A lot of times when we work in a lab, we think that we're the only ones that actually see that our work. But actually, if you're entering things into a system, well, those can be used for many, many things downstream that you didn't even intend on when you started doing it. The second is data hygiene. It was something that I heard in bioinformatics. In bioinformatics, it was 80% of the work is converting one file format to the other. And then data science, 80% or 90% of the work is just cleaning the data so that it's ready to go into your input. So this is something we're going to continue to struggle with. And then the third thing that I think is a critical issue is just the technical competency. And by technical competency, I don't mean that we don't have people that know how to build these fancy models. I'm really talking about a general awareness of what skills are necessary and who has those skills. So, for example, in IT and informatics, they both work almost exclusively on computers, but those two categories are not interchangeable. And even within those categories, there are immense variation. So I'll use the Olympic reference because we just finished that up, right? So we want an Olympic athlete. Okay, let's take ray gun and DTech. Everybody heard about Ray Gun, the break dancer from Australia, I think it was, and how she scored a 0 because it was mind-boggling to watch what it was that she was doing. And then you've got this Turkish shooter, DK, who just looks like a straight-up hitman out of Grand Theft Auto, you know? Now, those two are both Olympians, but they're not the same. They both had different events. So one was a breakdancer, one was a shooter. And the skills that you have for breakdancing are definitely not the skills that you need for that precision level shooting. And I think that's a great corollary to when we say IT or informatics, because IT, you've got networking people, you've got security people, you've got quality assurance people, you've got developers, you've got engineers, you've got scientists. All that's fine and good. Informatics is the same way. Well, I know DNA, I know RNA, I know proteomics, I know mass spec. So they are not interchangeable. And so just understanding the differences of what people's skill sets are and where you would find them, I think is one thing that I would love to see some improvement on just in general.
Yeah, so that Olympic example is great. I remember seeing clips of Ray Gun just absolutely bombing, and it was pretty hilarious. But, you know, how do we sort of take steps to fix these issues?
Great question, because I always hate it when people complain and then they never offer solutions. So everybody knows the hype cycle for AI is just nuts, right? And if you take that as value, then you're not going to get much out. Okay. So what I've been able to do, and a lot of people that I work with at similar institutions, is they take advantage of this hype cycle and they use it to get some of that non-sexy stuff like that data hygiene and data literacy. They say that that's a necessary prerequisite to doing good AI, because it is. And this allows us to say, hey, we're trying to keep up with the Joneses from the administrative level. But really, when you get down into those technologies, you start looking at the needs and you start saying, well, I need to clean my digital house before I can take advantage of all of these great tools just to be able to feed that pipeline. The other thing too is I've actually started to see some real ROI just by doing these things. So I have an example in one lab. People came up to me and they said, we want to use AI to improve test ordering, because there was a perception that we spend a lot of time going back and calling physicians that ordered a test because, are you really sure you didn't want this other test because that really fits the use case a little bit better? I'm a data scientist. I can't rely on that sort of perception. I need data. So what I did when I got involved with that project is, well, let's establish a baseline. And what I found was that 80% is due to just misordering 2 tests. Well, if it's 2 tests, then you don't really need AI to look at every single test that comes through. You need to take a look at the experience that the user has when they order test A or test B, and just simplify the test ordering language or change it in some way that eliminates those errors. That's not AI. But because we wanted to do AI, I had to do that foundational data hygiene work to figure out what was going on so that I'd have a benchmark to say, this is how well AI improved.
Yeah, and I think maybe one thing that you're touching on is with this AI hype cycle, some people are trying to, instead of using all the tools in the toolbox, they're just trying to use the AI tool and say, how do we solve this problem with AI? Because it's, like you said, it's a sexy term, and everybody wants to be pushing it forward and say that they're using it.
A lot of people take for granted sometimes of, well, let's solve this problem with AI. And you should really refocus that question to say, let's solve this problem. AI or not, if you use AI, it doesn't matter. Do you get the problem solved? And I think that would help drive a lot more collaborations to go a lot smoother. I've had people come to me with both, hey, I need your help to come up with some way to solve this problem. And I've had people come up to me and say, we need to build AI to do this. And guess which one worked out better?
So for many people, including healthcare professionals, AI has only gained widespread attention in the last 2 to 3 years with the rise of generative AI platforms and major tech companies. In the 13 years since you started, aside from advancements in capabilities, do you think there have been fundamental shifts in how AI technologies and applications are being pursued in healthcare?
So in anatomic pathology, when you look at a glass slide under a microscope, there are many subjective tasks that a pathologist needs to perform. That's why they get all that training. And this hasn't changed in over 150 years. You take a slide, you look at it under a microscope, and then you make some sort of diagnosis. The problem is in that subjectivity. So the only person looking at that, usually one person, one set of eyes, and they're making a decision based on the best facts that they can put together in their brain. And it actually turns out that a different pathologist may look at that same slide and have all the same data to make the same conclusion, and they actually come up with a different conclusion. It's also been shown that the same pathologist can look at the same data and may come to a different conclusion just on a different day. So this subjectivity is really, really scary from the patient perspective. So this has been attributed, we've actually looked at root cause analysis for this. And it's because there are complex cases that may have been seen earlier in the day. If you look at something at 5 o'clock, you're not as fresh as you were at 8 o'clock. Those sorts of things, just human factors. Even on top of that, you've got different skill levels in those different people that are actually looking at the tissues. So if you've got somebody that just graduated, they're perfectly capable of doing the job. But if you've also got a world-class expert in this very niche field looking at the same thing, you're going to get two different opinions. So this whole idea of subjectivity is really, it's worrisome to me, really. And so that's why my avenue as a data scientist has been to try and get to an objective truth, if at all possible. This is actually where digital pathology and coupling digital pathology with AI has done a couple of things. It's meant that more people can actually see the same thing. So it's not just who's ever physically in the room looking at the microscope. And it converts that physical asset into a digital one. So with a digital asset, you now have ones and zeros to describe that tissue, rather than this flowery language that pathologists are known for. It's fun reading. You'll have to look up what certain words mean because they're very unique and used by just a handful of people in the world.
Yeah, it's definitely my least favorite subject in med school for sure, because every single word is a word that you've never heard before.
You don't know, they say a picture's worth 1,000 words? Well, rather than using 1,000 words, just give me the picture. I'll know exactly what you're talking about. Now you can do that. You don't have to physically FedEx sample. It could get lost or damaged or broken, all of that sort of stuff. You just send a digital copy to somebody and instantaneously across the country, somebody has access to it. So that's great. But from the data science side of things, if I now have ones and zeros to describe a picture, well, that means I can run algorithms on it. And algorithms don't get tired. Algorithms don't have a bad day. Algorithms are going to give you the exact same result every single time they see that case. That's kind of where I want to do. And moreover, if you know you can send that picture everywhere, well, you can also send the analytics everywhere. So if I could send that model to be run wherever, well, now that patient, from the patient perspective, because, needs of the patient come first. Well, you don't have to be at a big city hospital or a Mayo Clinic. In theory, as long as you've got that image and you've got it digitized and you've got access to this model that's trained with some of the best data sets and experts in a particular field, well, that's great because they're now democratizing the best healthcare possible to everyone, everywhere.
Yeah, that's beautiful. And that sort of touches on, I know this is the U of M Twin Cities Medical School's goal, and Duluth as well. They sort of really prioritize primary care and making sure that we can democratize access to healthcare all throughout Minnesota. And I know Mayo Clinic is uniquely poised to do that because it's really the only hospital system in that area, the Rochester area. But let's talk a little bit about pathology and the outlook for pathologists. So you mentioned the algorithms don't get tired. They aren't subjective. One might say that over time, they will be just as good as pathologists, if not better. So what happens to pathologists? What does their job market look like?
This type of question is a very famous question because Jeff Hinton, it's probably 6 or 7 years ago now, that said this at a conference. There's no need to train radiologists anymore because AI is already better at looking at things than radiologists. But we still have radiologists. It just turns out that we have eliminated a lot of the things that humans aren't very good at and allowed the humans to focus on the things that they are good at. So I don't know if you know this, but humans are terrible at counting. Right? Count the number of mitotic nuclei in a breast cancer sample. Well,
Yes.
first of all, we're going to look at the whole thing because that would just take too long. So they look at 10 high power fields. And in those high power fields, they say, yeah, there's about 20 there. But do they actually count 20 or are they saying it's about 20? Or what percentage of positive is this particular cell? So that means there's a fixed number of cells and there's a fixed number of positive cells. And so you divide those two. But no, it's an eyeball. It's a guesstimate. So that's because we are not good at counting. Algorithms, on the other hand, are fantastic at counting. So if you ask an algorithm to count the number of mitotic cells or count the percentage positivity for a particular stain, that's going to already be way better than a human. But what people tend to leave out is that's not the only thing that they do, right? That's one step in a multifaceted, complex process. So for a breast cancer example, they have to count those high power fields. Well, first you have to detect those high power fields. So which ones are actually representative that you want to actually automate? Okay, well, there's another chance for an AI to come in and detect the high power fields. Even though if you have the whole tumor, why not just look at the whole tumor? Because, well, now that's completely different. It's just that there is more decisions than those single, very definitive things that we like to build algorithms for. That doesn't replace the pathologist. It replaces a step in the pathologist workflow. But there are plenty of remaining steps to go.
As medical students, I think there's sometimes a little bit of hesitancy to learn about this technology because there is a little bit of fear that it'll replace us at some point. You know, I have friends that are software engineers as well, and I feel like the people that are more well-informed in this space are actually less worried about it replacing them. He was like, there's no way it could replace me, even though it can help with a lot of programming. There's still a lot of things that it doesn't really get and things that I'm needed for, you know? So it's interesting that it feels like the people that are the most immersed in this space are sometimes the least scared.
Isn't that the Dunning-Kruger effect? The more you know about something, the less and less certain you become. And so if you're very certain that you're going to completely replace pathologists, that probably means that you don't understand what a pathologist does.
Yeah, no, that makes sense. So in your recent paper, Measuring What Matters, Intrinsic Distance Preservation as a Robust Metric for Embedding Quality, you introduced a novel approach to evaluating embeddings in unsupervised machine learning. Can you discuss how this method has impacted the field of digital pathology or its potential applications in improving AI models used in clinical settings?
So it goes back to my ultimate goal of always trying to find that objective ground truth. But when you're dealing with embeddings, these are multi-dimensional vectors that don't really have a ground truth so much, right? So how do you judge how well they're performing or which one of these is better? Because everyone else in the field, how they are measuring this, and this is usually done in the context of foundation models, right? So foundation models are the greatest thing since sliced bread. They end up giving you some sort of embeddings that you can then train a model downstream. We used to just call that fine tuning or frozen model weight transfer learning, but now it's something new. So we do that. And then, so what they do is they end up evaluating these different foundation models embeddings by doing some downstream task. And that downstream task is like a linear probing example. So in breast, it might be, we're going to take PyCon and PyBlue and Prob Gigapath and these other foundation models, generally the embeddings, and then do a logistic function on those embeddings to say, how well do they discriminate ER positive versus ER negative, and so on and so forth. But there's a fundamental problem with that. You've now just conflated two different issues. And I remember, I wasn't that good at school growing up, but I do remember this idea of the scientific method, where you basically want to keep all variables constant except for one. And in this sort of paradigm, you have multiple things going on. You've got your embedding quality that's the input to your secondary model for the logistic regression. And well, what happens when the ability to detect ER is not as easy or difficult as detecting HER2 or something even more complex? So now you've kind of mixed all these things together. So how are we ever going to get to a better? And so that's what we did with IDPE. Is we said, well, I think we can actually define better going back to the embedding space, leaving off this ancillary step. So without getting too deep in the weeds on what we did, is we can define a ground truth, let's just say based on image similarity. So we can tell you, because there's tools that are out there that have existed for a number of years to say, how similar are two images? If they're similar or dissimilar, they're going to have this distance measure. It's going to be a bigger distance if they are more dissimilar. Okay, so you can take that as a ground truth for imaging data, and then you can take the embedding models and you can calculate that same distance for different embedding models. And you can take not only the rank order, but the distances between nearest neighbors in your embedding space, and you can say which one of these is most representative of the actual distances that I observed in my truth set. And that ultimately is an error. So this way actually gives you a measure of which one is actually best that eliminates that downstream task.
Overall, it's, like you said, just a way to get closer to the ground truth. And that's amazing. I think these jumps in performance are stuff that is hard to quantify in the long term, the impact, but it's definitely in the good direction. So I would love to also touch on how extensively providers are currently using AI for diagnostic purposes, and are there any specific platforms that you've seen people adopt?
I think we actually have to couch our expectations about diagnostic AI, because there are all sorts of ways to interpret whether or not AI is being used clinically. So is AI being used clinically if it's used for hospital operations? Some would argue yes, some would answer no, but it doesn't matter. That's always happened. There's so little impetus to actually getting operational enhancements from AI. I mean, we're using it constantly. If you're using Copilot to summarize your meeting notes, you're talking about for things like workflow, you have to get everyone digital first. So not every process that we have in medicine is a digital workflow. Even in digital pathology, we're not still 100% digital. We still sign out cases the analog way in certain circumstances, because there's always caveats in medicine. There are actually clinical labs that work on Post-it notes and whiteboards. If you have ever been to a pathologist's office, what you usually see is they have a desk and a microscope, and they have stacks, floor to ceiling, of these little trays. And inside each one of these little trays, you've got piece of tissue that came out of somebody. That freaks me out. Every pathologist is like that. You go to their office, you see these stacks. Well, we got to get rid of that. There's a safety issue here of, clearly getting mistakes and losing and breaking. So got to get everybody digital. Specifically for diagnosis, well, is there a human in the loop or not? Because there are AI algorithms that are available for diagnostic purposes, but they have gone through a significant, rigorous evaluation by the Food and Drug Administration. And there are very strict rules and when you can and when you cannot use them. And most of them to this point still have this human in the loop component. So if you don't have someone at the end of the day that can sign off to say, yes, I agree with this, then who are you going to sue if it gets wrong? Are you going to sue the manufacturer? Are you going to sue the technician that actually ran it? The person that processed it to get it to that? There's all sorts of things that this digitization and this introduction of AI in diagnostics, questions that have never had to be asked before. And the last thing I'll say is using AI completely for diagnosis. Publishing a paper is not the same as a clinical deployment. Even if we could really see some of the numbers that come out of, if you look at publications that somebody produced a model that is 99% accurate and a human is only 97% accurate, that doesn't mean that it makes sense to use it for a clinical setting. Because A, you already do it well enough. B, what if that particular task is something that a pathologist could do all day and it's not really a problem for them? So you've solved the problem that isn't really a problem.
As you said, just because you published a paper on something doesn't necessarily mean that it's actually being used in practice. And I know all the time we see these papers published on, groundbreaking cancer drug, and, it still has to be pushed through the FDA, which takes years and years. But in your paper, you stated that the rapid pace of advancements in LLM technology often outpaces the publication cycle of traditional scientific literature. So given this, how do you navigate the challenge of staying current in a fast evolving field like pathology informatics, where the potential applications of LLMs are continuously emerging?
Okay. So I'm finally glad people are coming around to this idea of preprints. I mean, I was on this bandwagon many, many years ago when we didn't know what was going to happen. And there was a lot of resistance to get things out in the public domain because it's publish or perish in academia, right? So someone could theoretically, even though I've never heard of a case where that ever happened, but I've heard this argument so many times, it makes me sick. If you publish in a preprint, I mean, you're not technically published, but it's out there, you could eventually get scooped by someone else that's in a competing lab that's thinking about something similar, that looks at your preprint and then goes through the publication process faster and then somehow beat you. I'm glad we're not as worried about that anymore, because there's just no way. If it takes a year to get a paper published, because sometimes it does, things that are in AI a year ago are kind of old now. I'll give you a perfect example of this. If you use GPT 4.0 last week, I use ChatGPT all the time for lots of different things, not for PHI or anything like that, but I use it quite a bit. It's almost impossible to stay on the bleeding edge, because did you know that yesterday, OpenAI 01 was released?
Yeah.
And this one does more reasoning and analytical thinking and thinks before it speaks.
What does that even mean when they say it thinks before it speaks?
It actually tells you. I used it last night. I mean, I don't know how it works behind the scenes, but what it shows you in the interface is it breaks down those sections. Because a lot of the times when we ask questions, they're pretty complicated, and it breaks them down into their core components, and then it'll look at each one of those core components and it'll say, analyzing this, analyzing this, analyzing this. And you can see the different facets that it's working through. So you're actually seeing the chain of thought that's coming out from the model.
Yeah, and I saw a little discussion on Twitter about its thinking, and I know somebody was trying to prompt it to actually say what it was thinking instead of producing an output that was basically what OpenAI was allowing it to say. Is that something that you've thought about? Do you think we should have unfiltered access to these things or no?
There's a couple of complications with that. So this is an idea called prompt hacking, where people will put in a variety of text. There's a couple of techniques to try and do this so that you can actually see what the instructions are for the model. And that actually, I don't know why they hide these things, because we always find a way to do it. But okay, they just want to play this game. We'll have somebody else do it, and we're going to eventually figure out what's going on. The problem is these models are not thinking. This is a statistical model. It's just looking at correlations of words that happen in context with one another. Okay, so it's basically a generalization. It's not thinking, it's summarizing a generalization of a concept, not really, oh. So I'll give an example. I had this idea for a mechanism that I wanted to build in my shop, and it needs to be able to move a couple of 1,000 pounds from left to right. And it told me to use a windshield wiper motor. A windshield wiper motor cannot move thousands of pounds. It's not thinking. It doesn't recognize concepts the way that we recognize concepts. And we have to be very careful about people thinking that these models are actually thinking and they know what they're talking about because they sound so convincing.
So what will that threshold be, do you think? When will you be able to use a model and say, this thing is actually thinking, this thing might actually be digital intelligence?
It's one of those things like when the courts were taking up pornography. I don't know what it is unless if I see it, I can tell. We'll need some sort of analytical approach to know definitively whether or not it's actually reasoning and what does that actually mean.
Because you could argue that they already have passed the Turing test.
Yeah, and you can use it all day long and people don't know that they're not talking to you. So I think the tests have to evolve and our definitions have to be very, very clear.
You know, we can talk a little bit about what the implications for that might be. You know, nobody really knows what the future is going to look like. And I'm listening to an audiobook right now, this book that just came out, Nexus by Yuval Noah Harari, that explores humanity's history of creating powerful tools we often struggle to control, along with our tendency to misuse power. What is your perspective on the potential of artificial general intelligence, and are you more concerned or optimistic about its future?
Well, now we're in the speculative realm.
Yeah.
So take everything I was saying with a grain of salt. I'm more concerned people think we're closer to it than we actually are. I mean, yes, the AI in general, and especially these LLMs and transformers, I mean, they have fundamentally changed how I do my day-to-day job. So they have affected my life. A couple of years from now, we're not going to think it's all that impressive. And we'll kind of laugh at ourselves to think that, was that really that innovative? And that's because our goalposts are moving. We used to think that the internet was a big deal. And it was. It fundamentally changed how everybody does work. But we weren't experts at it at day one. And we still don't have internet for everybody. I just don't think we know how big we can get. And I don't know that we have defined what it means to say that we got there.
It's murky waters and we're all sort of swimming through the soup right now. And it's kind of naive to make such a strong prediction about how it's going to replace us or everything's going to be okay. You know, nobody knows. Nobody knows how it's going to turn out.
Yeah, but everybody's seen Terminator. We all do know how this ends.
It's sort of interesting because you can see that as humans, power does corrupt people, and these institutions like OpenAI that were originally open source now that aren't, that are more focused on profits. There's sort of a disconnect there, and the larger an institution gets, the slower it moves.
Let's use another tool as an example for a predicate for this idea of large group versus individual or a small number of people. So the tool that I'm thinking of is Fire. And we, in general, do a pretty good job of controlling it. We have lighters, and we can use it to weed our gardens and stuff like that. Then we've also got idiots like that Yahoo out in California that was just busted for causing line fire, I think it was. So we do these stupid things. Now, that's not we as the big we. That's we and then that one idiot. So I think as a whole, we're better off than trying to say that everybody's an individual, right? Because I think we have a good grasp of fire and the implications and the ramifications for not handling it properly. And other people either don't know or don't care.
You could also argue that the we doesn't matter as much in this situation because one company is going to ultimately be the first company to create artificial general intelligence if that ever happens. Does that resonate at all? Or
I mean, it kind of feels like that because trying to compete with the salaries that people like TikTok, Google, and Uber are offering. That's all short-term wins. The reason why they're doing that is because there's an arm race for the talent to be able to try and get to that point. But I would argue if they don't have the mathematical capacity to actually reach AGI. But that means that you have to find AGI and all these other things that we've already talked about. Problem is that we have 8-year-olds that can program video games.
Yeah.
Right. And this is all on a computer. And so what if somebody actually just figures out a smart trick that we haven't learned yet? Well, that doesn't mean that OpenAI is going to get it. Once they buy that technology and squash it. But there is opportunity.
I know Elon Musk was pretty upset with how his initial investment in OpenAI turned out, knowing that he initially put in $40 million under the premise that it would be an open source company. He's also pretty vocal right now about regulation and the pace of innovation that's being slowed down. You and your team have worked closely with the FDA on developing validation data sets for regulatory submissions, particularly in the context of mitosis counting using AI. Could you share what it's like to collaborate with the FDA on a project like this? And how does the regulatory environment shape the pace of innovation in medical technology? And how might this collaboration impact the broader process of streamlining AI model approvals in the medical field?
I am one person at Mayo, and I've had one experience working with one person at the FDA, Brandon Dallas, who's been absolutely phenomenal. I almost regret everything bad I've ever said about the FDA. Even though the intention was for validation of AI algorithms, what we were doing was actually trying to establish that objective ground truth. And just getting to that objective ground truth where we could have everybody agree on what would be a golden data set for all these validation companies, something that they had never seen before, and generating that asset took a lot of time and money and effort from skilled people, which involved the International Working Group for Tumor-Infiltrating Lymphocytes. Big deal for us to be able to get this. Now, whether or not people use it when they do an FDA submission, that's going to have to remain to be seen about whether or not they will. They don't have to use that. It's just an option. Okay. And that goes to show how complicated our regulatory process is if you have an if anywhere in your system, you've got a bifurcation. And then you have 2 bifurcations, and now you've got 4 possibilities. So this grows and gets exponentially complex. In terms of streamlining, that was meant to streamline the application so that people from these companies that were submitting to the FDA would actually have something in their back pocket that they could use to objectively measure the performance of the algorithm and not necessarily just take for granted or require a company that might be a small startup company to get access to hundreds of slides annotated by world experts to judge the value of their contribution. I mean, that's infeasible too. So, I mean, it's a win-win situation, I think.
I think it's pretty apparent for me and for all our listeners that you're quite a deep thinker and you don't like giving answers unless you really make sure it's reflecting how you feel appropriately. We met a couple of months ago at the Mayo Clinic Artificial Intelligence Conference, and you stood out for consistently asking thought-provoking questions. I'd love to explore that more with you. What, in your opinion, makes a good question, and how do you approach formulating one?
First of all, thanks for that. I wish I had an answer, but I don't really have a great answer because I don't really know. If I had to guess, it's probably because there is a genuine interest behind the question. I'm not after a gotcha. You know, sometimes it feels like that. I can be rather adversarial at times, you know, but, or the famous, I really have more of a comment than a question. It's not about you, right? That's what we have to do. We have to take us out of the question and say, well, am I really curious about this question that I want to ask, or do I just want to show somebody that I know what they're talking about?
I'm so glad that you touched on the infamous comment instead of a question, because it's just like, I don't understand what your goal was of just going up and saying a comment besides trying to convince the person that you're smart. But that's always been really funny to me, I guess.
Yeah, it doesn't work when you're looking for a job and you go up and say that to somebody and then try and use that to say, well, this is why I think you should have me as your postdoc because I can call you out in front of hundreds of people.
Yeah, and at the conference, there was a moment where you clearly disagreed with a speaker who was talking about, I think he was a founder or something as well. And, you disagreed with him and you pushed back on some of the responses he was giving you. And despite the difficulty and the scrutiny that you might face in that moment, it takes a lot of courage to stand in front of a room full of industry experts and play devil's advocate or openly challenge their views. How do you develop that type of courage?
Being stubborn isn't really courageous, but the real answer is to have conflict is actually a good thing. And I'm from the Midwest. I understand the Midwest mentality of no one likes conflict. Everybody's in agreement. But the problem is that when you get in a room full of people that agree with you, then you don't get alternative lines of thought. And in science, it's not about opinion, right? Every decision you make should be made in fact. And if someone challenges you about something that you may have not considered or offers data in opposition, it's your job to be informed enough and not take it personally, provided it's asked in a non-targeted sort of way, to rethink your assumptions. It's really hard to argue with data when somebody presents it to you and it doesn't become a cult of personality.
I think there's something there about being stubborn as a actual good trait, because your best trait or your best skill is swimming through waters that are uncharted and discovery. And innate to that is a dissent to the opinion that is common, a dissent to what is already known. You want to actually find out the truth, like you mentioned.
Again, it's not really about opinion. It's just about, okay, is that a fact? Or is there something where that fact came from that it was flawed study or something to that effect?
Let's dive further into a few life questions here. So you said you're from the Midwest. You are now in great state of Minnesota, land of 10,000 lakes. What's your favorite thing about Minnesota or the Rochester area in general?
Well, I wish I could say it's the lakes, but this is the one county in all of Minnesota that doesn't have a natural lake.
You have a river.
Yeah, but it's not the same. This is going to go back to my wife again, so I hope she doesn't watch this. No, she's from a small town, right? She's actually from a town of like 5,000 people. I'm originally from a town of 150,000 people. This is more in line with what I'm used to. Rochester's, 120,000 people? So it's the right size for me. I live out in the country. I have acreage, and I couldn't do that in a really big city. And a lot of the large AMCs, they're in a really big, expensive city. And So I live outside Rochester, and look at the house you could afford in Minnesota, and then look at what a comparable house would be in California. Life is more than just work.
I'm sure it's nice to be able to do whatever you want on your land as well. I think that's one of the nice things about certain parts of Minnesota. You can be close to like a metropolitan area, but also have land to have privacy. So, you mentioned their life is not just about work. Let's talk about that. What gives your life meaning?
The thing that gives my life meaning is that I don't define myself based on my job. So often we go into a social event and we say, hi, I'm so-and-so. I work at Mayo Clinic and I'm an AI scientist. Yeah, that's true, but I'm also just a normal person that likes drink beer and bourbon. And there's more to it, right? There's a lot of people, and I know you know some of them, and everybody knows somebody like this, especially in the academic realm, where, well, I need to work 16 hours a day and going in on the weekends and all this other stuff. And that's no way to live, right? You get your priorities mixed up if you think that's what is going to get you ahead. Because even if you want to take just the full science approach to looking at it, after a certain point, after 6 or 8 hours, you become less and less competent to do your job. There's been studies on this. So why waste that? Don't waste the time that you have. I like to have hobbies. I always got to keep myself busy because my mind goes. Now, the sad thing is one of my hobbies is actually, it doesn't get me away from my computer screen. I'm trying to mix my data science work. I found this data set on bourbon HPLC and LCMS. Wow. And so I'm trying to build an informatics solution that lets me look at these 120 different types of bourbons, say which ones it had, put them in a three-dimensional UMAP, and really say, oh, well, I should really try this one because I like these other two that are neighbors.
By HPLC, is that high performance liquid chromatography or?
Yeah.
Oh, interesting. So you're looking at the chemical compound.
Yeah, the chemical composition. What is it again, the flavor and the smell.
Have you ever been shocked by any of the chemicals that you've seen in a bourbon?
I'm still just working on the data processing part of it because I'm not a mass spec person. So I have to learn how to analyze mass spec. Like I said, I have a real problem. My last hobby was learning about quantum computing because it's hard for no other reason other than it's hard.
Could you tell me what your favorite...
That's pathologically wrong with me.
No. I feel like that's beautiful. And, the constant desire to learn is amazing because you're not just applying it to your job. Like you said, you're applying it to everything. And you're going to, hopefully that'll make your mind sharp forever. But I would love to ask, what's your favorite bourbon?
Okay, don't hate me, but it's Blanton's. It's always supposed to be an MSRP of about $65. But on the secondary market, it's 200. And it's very, very hard to find. But it's really good. It's a lot of hype because it showed up in a John Wick movie. And so now you can hardly ever find it.
Okay, well then I won't ask you how you find it then, because you gotta keep that one close to the chest.
You gotta know people.
Okay, now I know why you did a study with the FDA. Let's wrap this up a little bit. The future is really confusing for a lot of young people. We don't know what the future is going to look like with the advent of AI and all the topics that we talked about today. What advice do you have for younger generations?
This sort of idea that we could know what we wanted to do, it shortchanges ourselves. I mean, well, my granddad was a doctor, my dad was a doctor, and so I'm going to be a doctor. Okay, well, yeah, but do you really want to do that? What if you wanted to do something else? You have to think, and you can't plan your life. There's no way. If you met me in high school, where I was like middle of the graduating class with my GPA, you'd say I'd be working at the Mayo Clinic, or that I'd have even gone to college or got a PhD. I mean, these were things that were outside the realm of possibility. So don't try to plan. Just go with it. And if you go with it, you ride that wave, you actually direct where that wave goes, which at the same time makes you more valuable because you're familiar with this wave. You can help direct it and then make yourself stand out when you're looking for your next job or next opportunity, because you're only going to know by doing.
So be open to life's possibilities and
just let it come.
Go for the ride. Dr. Hart, this was an amazing conversation and I've learned so much. I know all of our listeners will be really happy. Do you have any parting words for us?
Find something that motivates you and use it to your advantage. Mine was being stubborn and proving other people wrong. Yours is going to be something different. You can't just copy anybody. As cliche as this is, you do you.
Just do you. All right. Dr. Hart, thank you so much. It was a pleasure talking with you, and I can tell you're a genuinely great human being. If I'm ever up at Mayo Clinic again, I would love to touch base with you and try some of your bourbon stash.
Sounds good. Thanks, Nathan.